Sonam Bajwa on a Friday night is the best thing in the world. Any Punjabi song and this actress, it's a nice Friday night celebration. Hello everyone, welcome to a new video. This is the third part of the full stack series. It's a Friday night and I am going to Dubai tomorrow for the NAS Daily Summit. Extremely excited about that, but I thought before I leave for it, might be good for me to complete the commitment that I've made on YouTube, which is a full stack web dev series. This is the third part, part 1, Backend. Around 70,000 views. A bunch of people have actually created real contributions on it. Let's check out how many contributions we have by now. We have around 340 people who have actually created pull requests. I went through a bunch of these and kudos everyone. React, not a lot of people were able to do from what I could understand, which was the second part of the full stack series. Only 49 submissions, which is totally understandable. I think React as a technology is slightly harder to understand than Node.js, but that's totally fine. Don't worry about it. This video is going to be a little deeper, slightly deeper dive into React. But I think in video 4, in case you did not yet understand React, we'll be writing a bunch of new components. So you'll be able to basically practice more. And React is basically the more you practice, the more you sort of learn. A lot of times you write bad code initially and slowly you realize this is what you should do, this is what you shouldn't do. So don't even worry about it. This video specifically is the third video. We are going to pick a very nice front end that our friend Arghya Das. Forgive me if I butchered your name, Arghya, but this is like a beautiful version of leetcode that our friend has made. So I'm going to use this code. They've open sourced it. They've created a pull request. I am going to fork that, and that will be our initial point for the front end. The backend I'm going to rewrite very quickly in front of you guys because I saw a lot of backend submissions. There were a few things missing, mostly around cookies and headers, basic authentication, which I want to sort of write from scratch and also teach while I do. So the backend code is rewritten by me. The front-end code we're going to use by this guy, and then we're going to connect it and deploy it on the internet. I have bought the domain name neetcode.com, which is like very similar to leetcode.com. I hope they don't sue me. This is not a business that I'm trying to build. It's like a fun project. It'll probably stay up for a few days and then we'll take it down. So we'll be actually deploying it on the internet. After you've written your code, the best thing to do is showcase it to the world. And the way to do that is deploy it somewhere. We'll be using very lean machines. So if you do it yourself, you won't be spending a lot of money on a monthly basis, almost zero for front end and a little bit for backend. So that's the gist of what we're doing. By the end of this video, we have neetcode.io, which is an algorithmic problem solving platform that you can go and solve problems on ready. The only missing piece would be when you click on submit, it doesn't yet evaluate your submissions. The reason for that is the difficult part. That is the part that's sort of very hard to build. That's the moat of a lot of these businesses. The word of the video is moat. Tell me what it means in the comments down below. And that's the part that's difficult to build. If you saw my video recently around layoffs, I said you should understand something more than full stack. The thing is, anyone can build websites and anyone can sort of build something like LeetCode. But what's hard to build is the backend that processes the actual submissions. And the reason for that is there are a few reasons. One, that's hard to build in itself for every language that's out there. And two, you can't let other people run arbitrary code on a machine of your own on AWS or on GCP. And the reason for that is they could write code that has access to your file system. They could write code that keeps on running forever. They could write code that could blow up your machine. And hence you have to make sure the code that you're running that's provided by your end user on LeetCode, for example. Here, the code that I'm writing here is actually being run in a LeetCode backend machine, and it's being run in a very containerized environment. That's the difficult thing to build here. I am creating a bounty right now. So in this video, we're not completing this. We are not writing the actual logic to process these. We'll actually randomly return like an accepted or a reject. But here's the bounty. If you can create a backend system that pulls problems from a messaging queue like RabbitMQ, processes them, runs them in a Dockerized environment, auto scales correctly if the number of problems go up by a lot, and is able to handle a load of, let's say, 20 problems a second or something like that, I will give you a pair of AirPods, ye MagSafe charging case AirPod 3rd generation. If you're able to, I will repeat, create a backend system. This is actually a DevOps assignment. This is like not really related to full stack. The backend system should poll a queue, a RabbitMQ queue, a Kafka queue, could be either, where the user submits a problem. The process should be able to pick up messages from the queue and create containers or process them in containers where the submission for the user will run. And if it takes more than 2 seconds, then it will return a TLE. If it does not match the right outcomes, it will return something like this. If there's a syntax error, it will return that. If it passes all the test cases, it will return an AC, and it should auto scale. That means if you get 100 messages together, should be able to increase the number of containers, the number of nodes that are running, and like go up and down. Cool. I think this will take you like a lot of hours, like probably not worth it for the AirPods, but probably worth it for the learning experience. So if you want to get into DevOps and want to get ahead of me and do the fourth assignment, or this will probably come on the fourth or the fifth assignment. If you want to do the fourth or the fifth assignment before I do it, the first person who does it and is able to tweet at me on my Twitter will get the pair of AirPods, as long as you're in India. I'll ship it to your place. Cool. With that, a lot of context before this video. Let's get right into it and let's do the first thing here. The first thing we have to do is fork our friend Arghya's project locally. The way to do that, this is Arghya's pull request. So I can't really clone it from here. I have to go into his user and his fork of my project here. And the branch that he created the pull request from was his name. So basically, this branch right here, I need to clone this branch into my local machine. What am I doing? Arghya created a pull request. He pushed his code here into the forks that he's created. I want his fork locally. I don't want to clone my own project. My project is fairly empty. It was an assignment. I want to clone his changes that he has done. The way to do that is clone this repo right here. Go to the terminal. Let's create a new project called leetcode. So it's like a fresh project. Inside the leetcode folder, let's create a client folder, which is basically the front end. And now I want all of his code in the client folder here. The way to do that is, let me open another terminal. I'll create a new folder called temp. I'll cd into temp. And then I'll clone our friend's project right here. So what I'm doing, I'm getting his project locally into my machine, into a new folder for now. And then I'll copy it over into the client folder of my leetcode project. I'm basically taking away all his contributions, stealing them, copy all the files from here and paste them basically in the client folder right here. So now our client folder basically contains all of Arghya's code, and I'm going to now remove the temp folder. So thank you, Arghya. All your contributions are now gone. Apologies for that. I mean, I'm just kidding. Like, of course you get all the credit. Now, one more thing to do is we have the client. We also need the server code, which, as I told you, I'll be writing from scratch. So let's create the server folder. We now have two folders. Let's open this up in WebStorm and go from there. So ladies and gentlemen, what we have here, we have the client code. If I go to the client folder, I'd run npm install. And then if I run, what's the command? npm run dev. So if I run npm run dev here, I should most probably see the leetcode or leetcode. There you go. Look at the comments in app.js as a starting point. So let's go to app.jsx. What are the comments here, sir? We have all the local problems. Let's just look at the routes. There you go, /login. Let's go to /login and we don't see anything. What am I missing here? Who will tell me what I did wrong in the comments? Come on. I did something wrong. Okay. What I did wrong was when I created the temp folder, let's do that again. Then let's git clone the thing again. I did clone it from Arghya's project. I did not change the branch. So I'm still looking at the main branch from his project, and the main branch only has my code. So basically has nothing that he has contributed. I should first switch the branch to Arghya's branch, and only then will I be able to see his code. Okay, let's do the cloning again in the temp folder. Let's go to the React assignment folder. Let's do a git branch. I'm currently on the main branch. Let's do a git checkout Arghya hub. And now I'm on the new branch, which contains his code. Now do the whole process of, first, let's just delete the client folder. Let's create the client folder again. Let's open the React assignment in the new right branch now. Let's open the client folder and then let's just steal all his contributions again. Copy, paste, there we go. And now if I go back into WebStorm and if I go to the client folder again, I run npm install again, and if I run npm run dev now, I should hopefully, there we go, we see leetcode, a bunch of blogs, a bunch of problems. If I click on a problem, it takes me to the problem. Beautiful. Let me submit the code. Cool. Now we have the front end running locally. We need to write the backend. What are the backend routes needed? I've discussed this in the first part. The backend routes needed are: 1, for letting the user sign in and sign up; 2, getting all the problems from the backend, just their title, their difficulty, and their acceptance rate; 3, given a certain problem ID, getting the description of the problem as well, along with the title. And then 4, maybe a route where when you click the submit code button, it randomly gives you right now an AC or a reject. Is that good enough? That's good enough. I think they've created blogs as well, which we will ignore for now because Well, that's like a whole different thing that we have to create. So now let's get into writing the backend code. सांस आ रहा है सबको? Can everyone breathe? Are we doing good? Are we doing bad? Let me know in the comments. Not that this is like a recorded video, not that it'll matter. Cheers. Backend code. I'm going to like speed run through this because we've done this too many times now. CD server npm init. Right now it's an empty folder. If I look at the server folder, if I do an npm init, it'll create a fresh empty package.json for me. I have to add express here, which is the HTTP server that we're working with. Then I'm going to do an express boilerplate, or just go to expressjs.com, copy over the hello world, paste it in like an index.js file. Try to create like a new script here called start, and then start script should simply do node index.js and then call npm run start. Now we have our backend running almost. We have something already running on 3000, so let me stop that. As you guys know, I have a full-time job, which means I have other processes running, other React projects that run on 3000 is a very busy port on my machine, to say the least. So let's kill the process, which I just did. And now if I run npm run start, I have something running on localhost :3000, and that returns me hello world, which is basically this route right here. Now let's get into some coding. Give me 5 minutes. Let me speed run through this and create all the routes. One small thing to keep in mind here, I'm not yet connecting this to a database. Why are you not connecting this to a database, Arghya? That's like the very basic thing you do. That is a very basic thing you do, but that deserves a video of its own, where we understand SQL, we understand joins, we understand indexes. If I create a database right now, it'll just confuse you, and also like you won't totally understand databases. There are also 1,000 databases out there now. Like there's Prisma, there's GraphQL, a layer on top of databases. There's SQL, simple SQL databases. There's NoSQL, there's Mongo. So not to confuse anything and keep things very generic, we're understanding full stack development here. I am going to store everything in variables for now, and then maybe in the next video we understand databases and add a database to this process. Cool. Speedrun starts now. Okay, so I've finished the backend code that I've written from scratch myself. Quickly, I'll show you guys, and then we'll test these routes out as well. What are the routes I've written? I've hard-coded problems for now, so no one can add new problems. There are 8 problems here. This is the backend. Again, this is not the front end. We have hard-coded them in the backend. We have a slash endpoint that just returns like hello world, basic health check endpoint. It doesn't do anything else. We have a slash problems endpoint. This is unauthenticated, open to the world, very similar, maybe not similar to LeetCode. LeetCode may or may not give you problems if you're not yet signed in, but our platform does. So if you hit the slash problems endpoint, you'll get all the problems. You can actually test this in Postman. So let's test this right here. If I do a get on problems, I get back all the problems, only the problem ID, difficulty, acceptance, maybe the title as well actually. Why only these fields? Well, we need to show these problems here, and we only need the title, the difficulty, and the acceptance rate. We don't really need the complete body here, and hence there's no point of returning the body of the problem unless you need it. And hence we've basically filtered out just the problem ID, difficulty, acceptance, and title for now, and that's what we're returning from the backend. Cool. There's a slash problem slash ID route, which will return you the complete problem, which has the title, description, everything. And why do you need this? You need this for this page, which will show the problem title and the description and everything else. So if I hit this in Postman, I'll see the complete detail of the problem, and we'll eventually be using it here on this page. What else do we have? We have a slash me endpoint that gives you the details of this user. This is usually used for, like, if you see your email or your avatar on the top right, you basically check whether or not you're authenticated when the first time you hit the website. Let's say you've logged in, then you go out and you come back in a few days and then you refresh. you basically need to either see a login button on the top right, or you need to see your profile name, your email. That's why you usually expose like a /me endpoint. That's what we're doing here. If this user exists, then we return the details of the user, else we basically return a 403. But where does this 403 come from? Rewind to the last video, the interview preparation video, where I described middlewares. The question is, what are middlewares in JavaScript? Now, this is actually a very vast concept. They're also called extractors. So what you just saw was me describing middlewares, and here I have defined a middleware called auth. Maybe before we do that, let's first look at the sign up and sign in endpoints. So if you look at the sign up endpoint, it takes email password as input, checks if the user already exists. If they do exist, again, we're storing everything in memory. If they do already exist, we return email already exists and a 403 status code. But if they don't exist, we push them to the users array. We increment the user ID counter, which starts from 1 and keeps going up, and we return the success message. So fairly simple, small y stuff here. The login route is slightly more important. Now, we first check if the user exists. Then we confirm that the password that the user has provided us in the body of the request is the same as the password as we have for this user. Then we create a token here. How are we creating the token? We're using something called as JWTs or JSON Web Tokens, which are a way for you to create tokens and store data in them in like a secure fashion. You have a secret that your backend knows, your frontend does not know. And using this secret, you can sort of take any data and encapsulate it, or like sort of think of it like secretify it or compress it. So you get like a token, a very random, weird looking token from it. And this token can only be verified by your backend or anyone else who has this secret. And we'll make sure we don't expose the secret on the front end. And hence our users don't really know the secret. And this token, as long as the user provides us this token, we know this is them because we're the ones who have sort of compressed this token with this ID of this user. So we return this token to the front end and then expect in every future request, if you want to access a route that's authenticated, you need to pass in this token. Where do you need to pass it? Well, let's go to the middleware and check that out right here. The middleware.js file has this auth attribute that's exposed. It takes in 3 inputs, the request, the response, and this function called next. As I explained in the last video, this is a middleware. This will grab data from the request, check, verify it, make sure it's right, and then only if it's right, will we actually call the function that's using this middleware. For example, this function, the post/submission. If someone wants to submit by clicking this button right here, we need to make sure it's an authenticated user. Hence, the auth middleware will run first, and this auth middleware will extract the token from the header, rec.headers of authorization. And I'll show you very quickly what headers are. I explained it a little bit in the first part of the full stack assignment. Headers are another thing that your user can pass when they're sending a request to the backend. We want the user to pass in the token that we gave them while they were signing in, this token right here. We want them to provide us this token in the header, and as long as they do, we'll be able to extract it here. We'll be able to verify using the same JWT secret that this auth header is correct. If it is correct, we'll get a decoded.id. This ID is basically what we compressed here. And if we do get back an ID, that means this user is authenticated, and hence we set rec.userid to this ID that we decoded. And if we don't get back a decoded.id, or if this function fails or anything else happens, we return a 403 status code to the user, which is forbidden, which means they're not logged in, they're not allowed to hit this route. Hopefully that was clear. This is very important, middlewares. There's like one middleware, you might have to introduce more. What this does, this extracts the header, ensures that the header has an ID inside by decrypting it using the JWT secret. This is the same secret that we encrypt the user ID from when the user signs in. So the user signs in, gets back a token. Any future request they're sending, especially on a route that's authenticated, they need to send this in the header. How they do that, I'll show you very quickly. But this is the gist of the backend. There are a few more routes that I've exposed. The post/submission, which basically lets the user submit for a certain problem ID. This is the post, and we randomly select whether or not their submission was correct by checking if math.random is less than 5. If it is less than 0.5, we say that it's correct. If it's greater than 0.5, then it's not correct. Basically, with the probability of 0.5, we're currently giving the user an AC or a wrong answer. In the future, we'll make this right, or someone else will and win a pair of AirPods. And if it is correct, we push to the submissions array this submission, the code that the user passed us, the problem ID, the user ID, and the status accepted. If not, we push to the submissions array, status, wrong answer, and then there is a get endpoint where a user can get all the submissions for a given problem. On LeetCode, or generally, you want to sort of see the last set of submissions that you have made, and that's what's exposed using this endpoint. Given the problem ID, we filter the submissions and we get the submissions for this problem ID for this user and return it on the front end. Again, this is an authenticated route, and hence first everything goes through this middleware. Cool. Let's test all of these out in Postman. So Postman is a tool that lets you send HTTP requests. The first request that we're sending is the get request to slash, basically this route right here, and it returns us message hello world. So basically things seem to be working fine. Now the next thing the user will do most probably is sign up. So let's hit the sign up endpoint and send somebody. I've created an email, created a password. Let's change this to harkirat2@gmail.com, and the password is 123 random. If I click on send, it returns me an error. It says cannot get /sign up, and that's because sign up is a post. Once you do that, it gives you a message success, which means the control reached here and everything was correct, and finally it returned the message success, which means our server now contains this in the user's array, which means the user can now log in as well. If I go to log in and send in the same credentials, let's send the wrong credentials first, 123 random 1, it says incorrect password and the status code is 403. If I send the right password, then it returns me a token. Beautiful. What do I do with this token? Any future request that's authenticated. Let's look at an authenticated request. The /me request is authenticated. So let's send a request to /me. It should be a get request, and let's not send any authorization headers yet. And it says, hey, missing auth token. Let's send a random header. Well, a weird error came. That's because the JWT is malformed. You should add a try catch there and make sure you return a nice message. But if I send the right token here, it returns me my email, password, and ID. You should never return the password. This is wrong. Clean that up, create a pull request. But you should return like the email ID of the user, so that when the user comes back to this page, maybe refreshes, we hit the /me endpoint and we can show them their email here at the top right. Cool. So now authentication works as well. Let's do a get on all my submissions for problem number 1. It says, dude, you've done no submissions, and that is totally correct. Let's actually do a submission using a post for problem 1. What do I need to send in? I need to send in the problem ID at the submission. So problem ID, let's say 1, submission. How do you write C++ code? Hashtag include dio.h int main submit. And it gives me an error that says cannot post on /submissions. That's because the post is on /submission. Let me send a post, and it says status AC, woohoo. Send another one, it says AC, another one, wrong answer, another one, AC, another one, wrong answer. It'll be like basically give me random outputs based on the probability of 0.5. Now if I do the get on the /submissions for problem 1, it should return me nothing. Why is that? That is because I know what that is. When I'm doing a post, I probably need to the problem ID needs to be a string. I think most probably that's the issue. So let's try this one more time. Few more submissions, and then let's do a get. When we do a get, we get back all the submissions that I made. Only thing I have to keep in mind is when I'm doing a post on the submissions, I send in the problem ID as a string, not as a integer. So all of our routes seem to be working. Basically, our backend is working as expected. We just need to connect it to the front end now, which is again difficult bit, or might seem confusing. It actually isn't. The only thing we need to understand is 1, how to update state in React, and 2, how to send HTTP requests from browser. Those are the 2 things we need to know. So let's first understand how you can send HTTP requests from your browser. Let's open our client code. Let's go to source. Let's maybe start implementing the sign up route. We'll dumbify it for now. Let's pause, take a break. What have we done? Completed the backend. What are we doing? We're now finishing the front end, basically connecting our front end to the backend. What will we do after this? We will deploy it on the internet. Cool. Take a break or take a breather. Digest everything we've done. Maybe go through the backend code, maybe set it up locally, run it locally, and use Postman to fiddle with it. You basically have a running version of LeetCode now. Only the client isn't written. Like we've used Postman as a client here. You can use mobile as a client. You can use web as a client. Your backend server now exposes everything that any future client could be like a native application, could be a browser application that can now interact with the backend and sort of use the functionality of coding basically. Now, the first thing we need to do is implement the sign up route. So the way to do that is let's look at where this is exposed in the front end code. Let's go to the client. Let's go to app.jsx. Here, if you look at the /login route or maybe the /signup route, this component is rendered there. For the people who haven't done the second part video assignment, this is how you do routing in React. Basically, like one of many libraries that lets you do routing in React is React Router DOM. So that's what the person over here has used, and based on the current route that you're on, it basically takes you to a certain component. The one we're worried about right now is the /signup component. Why are we worried? We're worried because it needs like a button that our friend forgot to put, but we'll just copy that over from the problems page and let's paste it in the signup page right below the third input box. Let's also remove name for now because our backend doesn't yet support it. Sub next sign up and then on click equal to alert hi. Okie dokie. So now I have a form where I can put in an email, I can put in a password, and then I can click on the sign up button, which right now alerts. What does it need to do? It needs to send a request to our backend to sign up. Basically what we did in Postman right here, the /sign up request, the first request that I sent out, this one, I need to send this request out from JavaScript. The way to do that is using fetch. Well, there are many ways to do it. One of them is this. Let me show you how to do that. You use the fetch API, give it the URL, which in our case is this. And I think, what else do you give? Method post, and you give the body, which in this case is email word. Where do email and password come from? They come from the state. We have to define email, set email. So if you remember in the second video, I introduced this thing called state. This, as I told you, there was something that React looks at, and React only re-renders when the state changes. One, there are many ways to deal with forms on React. Like there are a bunch of libraries that make it easy, but the most native fundamental way is anytime the user changes their email or password, these fields, you store them in state variables, which I've defined here. If you remember, useState is the hook that we use to define state. And what I'm doing here is anytime the input changes, this onChange event is fired, it gives you the value inside this HTML box in e.target.value. How do I know that? Well, let me quickly alert e.target.value here. When I refresh and if I type something here, AS I see, or AW, I see AW here, which means e.target.value contains what's written inside. And that's exactly what we need to store in these state variables. Why do we need to store them here? We need to store them here because when we're sending out the fetch request, we need to know the email and the password that's written in these fields. Now, is there another way to do it? There is another way to do it. You could give this input an ID, for example, password. And then here you could be like, okay, the password is document.getElementById password.inner HTML. So that's another way to do it. But usually when you're dealing with forms in React, you store these things that the user has put in the state, and then you use those states variable when you're actually sending out the request using those variables. That's what we're doing here. Let me, before I do any of this fetch, let me alert email and alert password, refresh, put in something, submit. I see the email, I see the password. So we have the right values here. Now we need to actually send the post requests to our backend to actually sign up, to tell it, hey, this is a new user that wants to sign up. So let's do that now, unless I'm missing something. I think we're good. Let's actually get back the response from this fetch and store it in this variable. So what I've done here is after I send the request, I get back a response. I extract JSON from it by calling response.json. This is like the standard way to extract JSON from the response that you just got. And then I'm simply logging it. Most probably, hopefully, I should. If I do it from Postman with a random ID, I get back this message success. Hopefully I get the same thing here. So let's refresh. Let's put in an email, sdsd@gmail.com, password 123 random. And just to make sure I can inspect this, I'm going to open the networks tab so I can actually inspect the request that's going out. Click on sign up. So one thing I've done here, I'll have to check why this is happening, but I have to call e.prevent default at the very top. Oh, this is probably inside a form. Okay, going to remove this form, and we should be good to go. But the original user who wrote this basically encapsulated this inside a form, and whenever you click a button inside a form, it sort of sends a post request. Ignore all of that. I just had to clean this up a little bit, and now I probably don't even need this e.prevent default because we're no longer being redirected. Click on this button, send a request to the backend. One thing I missed was that the route is actually /signup. Now let's try that again. I broke the designs, sorry. So I just converted the user's form to a div because this class name has the styles that makes it look pretty. If I remove this div, which I did originally, it just looked pretty messed up and we don't want that. Cool. Let's try this one more time. I just need to make sure that the route is right here. Remove this. We're good to go. Neatcode1@gmail.com. Single dot. We increase the font size and 123 random. Perfect. Make sure that the request is going out. Click on the sign up button. Are you guys ready? Clicked on the sign up button and I got back a course error. What is this course? Oof. Long story short, whenever you have a backend server, a lot of times you don't want any browser or any website, for example, localhost 5173, to send requests to it, and hence they are blocked via CORS. CORS stands for cross origin request, which means our backend is on the origin localhost 3000, our frontend is on the origin localhost 5173. We don't want any browser who's not running on localhost 3000 to send requests to the backend unless you explicitly mention this in your Node.js server. How do you do that? Well, you first have to install a dependency in your backend called CORS, and then you do simply const CORS equal to require CORS and then app.use CORS. I think this should be good enough. Let's try that one more time. Sign up, sir. Seems like the request went correctly and the preview, the response gave us message success. If I look at the console, message success is printed, which means when I sign up, the request that was going out in Postman and we were getting back a message success is now going out from the browser. We've started implementing this. Again, this is running locally right now. We will deploy it on leetcode.com, but in a local setup, this is working as expected. You now know how you can send HTTP requests from your browser to your backend. What's the way to do it? Quickly to summarize, well, you first have to go to your component that you want to send the request from. You have to add an on-click listener on the button where the request should actually go out. You have to make sure you store these in state variables. How do you do that? You create state variables at the top using the useState hook. You make sure anytime the input changes, you set the state to e.target.value. Once you've done that and you're ready to go, you use the fetch API that the browser provides you to send the backend request. And you provided the right set of inputs being the URL, the route, the method, and the actual body of your request. Cool. This is a good breathing point again. Breathe in, breathe out. Let me grab some coffee and be back in 2. Cool. So you were able to sign up. Now the next thing you have to do is log in. Let me just keep this email handy because we'll be using this to sign in. Let's go to login. Let's add a button there similarly. Login.jsx, remove the form thing. You are making it a div. Remove this action method. Remove name. Maybe just copy over the inputs from here because, well, we have the right set of state variables setting here. Copy over the button as well. Change the button to send a request to /login and add the 2 state variables at the very top. I think we're good to go. Or did I speak too soon? I might have spoken a little bit sooner. Import useState from the right place, refresh, and here we go. We now have the login page. Looks very similar to the sign up page. And if I put the original email here and the password, this should probably say login and not sign up. Let's change that as well. Inspect, network tab. What do you think should come back when I click on login? Should you get back message success or should you get back the token? Well, the /login, if you remember from Postman, actually returns you the token that you need to send in the headers of all future requests that need to be authenticated. So let's click on login. And what did we get back? We got back a token indeed. We are actually able to log that token here in JSON. So JSON.token basically contains that token because, well, JSON is an object, as you can see here. JSON.token contains that token. What should we do with this token? This needs to be stored in the browser. Why in the browser? Well, you will change pages now. If you store it in the state, it will remain in this component. You could store it somewhere else in the state, but it won't persist across refreshes. You need to make sure that the user, if they close this tab and come back after a few days, they're still logged in. And hence, what you need to do is you need to store this token that you just got inside your browser's local storage, which is sort of a place where you can keep data forever until you actually clear it. It's sort of the place where people keep tokens like these. The way to do that is local storage.set item token, this token. Okay, let's refresh. Let's try that one more time. Let's click on login. I'm sure the backend returned us a token. Let's go to application. Let's go to local storage and see if there's anything stored here. There is a token stored here indeed, which looks something like this. So we're actually getting very close now. Our browser is able to store the token. We just need to make sure the request that we'll make from this problem, basically this thing right here, we send the token in the header. And the other thing we need to make sure is when the user refreshes, comes back in here and they're already logged in, they don't see sign up and login. What do they see? They see like a logout button here, right? So let's first make sure we're getting these problems from the backend. So let's go to the /problem set/all endpoint. The way to do that is go to app.jsx and look at the problem here. So it seems like problems come from the very top here. Let's change that. We don't want these problems hard-coded in the front end. So if we go to all problems here, let's not send these in as props. What we're going to do is we're going to introduce a new hook here, use effect. Who's going to tell me in the comments what that is? Let me quickly write some code and then let's discuss this. Okay, so important concept here. There are two very important hooks in React. The first one is use state that we've used for a while now. It basically lets you store state in React, for example, email and password, and then your components are re-rendered whenever this state changes. The other important one is use effect, which reacts to state change. What do I mean by that? Use effect is sort of a function that takes in a function as input. It's not exactly a function, it's a hook, but for simplicity, it takes two arguments, the first one being a function, the second one being an array. The array represents a bunch of dependencies. It basically means whenever this state variable changes, for example, if I put problems here or any state variable here in the dependency array, anytime this changes, we know React re-renders, right? Anytime a state variable changes, React re-renders and you sort of see things change on your UI. But if you want JavaScript to run anytime your state changes, you use effect. You say, hey, anytime this dependency changes, run this function again. And a hack in React is if you don't pass in any dependency here, you will have the init function run once, just once, the first time that all problems page is rendered. And when is all problems page rendered? It is rendered when you're on the route /problem set /all. Though again, to summarize, when you hit /problem set /all, this component gets rendered. Inside this component, there's a use effect that has no dependencies, which means first time this gets rendered, call the init function. What does the init function do? It gets from the backend all the problems by using the /problems endpoint that we've discussed many times now, stores them in the state variable called problems. So basically, if I don't run this, if I refresh, I see no problems because, well, we did not fetch any problems from the backend. Before this, we were getting these problems from this front end, which we don't want. We want it from the backend because the backend will sort of add more problems, remove more problems. You don't want this hard coded in your front end code. And the way to get that is send the get request to the backend, which we exposed right here. app.get /problems, filtered problems is equal to whatever, and then returns the problems. So we get all the problems, store them in a variable, and then that's what gets propagated here. Why is this cool? This is cool because if I go to server index.js and change some problems, let's say I change the first problem to say 301 bitwise or, and I restart the backend process, I see 301 here as well. So we only have to make changes in our backend, and like in the future in our database, and our front end for everyone will change automatically. Versus if we hard coded this in the front end, like this guy did right here, which was the right thing to do for the assignment. But like eventually we have to put them in the backend. If they are hard coded in the front end, we sort of have to make a front end deployment every time we want to change problems, which is like not the right way to go about it. Cool. So now this problems array is slowly becoming obsolete. So we don't have to pass it here anymore because we're not using it. The other place that uses the problems array is the problems page. So let's not send it here as well. Let's go to problems page and let's get that specific problem now. We get the PID from use params, which basically means if I click on a problem, this /:2 we extract. Once we've extracted and kept it here in the clean ID variable, we need to fetch it from the backend. So basically I just redid what we did for the all problems page. I introduced a hook, which will get called once the first time this page is rendered, and it's going to call the init function, which will get this specific problem. So /problem/ the problem ID, which this user, the person who wrote this code originally, extracted from the params at the very top. And now that we have that, we store that in the problem variable, which is then what is used to render the title here and the description here, so on and so forth. So now we have a very nice dynamic website that's being built. The /problem/1 endpoint gets the problem from the backend. If I change the problem in the backend right here, and let's say make it 401. And if I refresh the front end now, I basically get back 401 because now all of this is coming from the backend. In fact, the app.jsx problems array that we had, basically the array that was hard coded in the front end, can totally be removed. So the file looks much cleaner now. The front end does not have any logic, any problems. They're all coming from the backend. The only endpoint, well, two endpoints that are left to implement now are one, what happens when you click on the submit code button, and two, fetching all the submissions of this user for this problem and then maybe showing them here or on a different page. Let me implement the first one. You guys will implement the second one. Cool. So we already have the problems page. We also have this button. Let's remove one of them. Here we need to add an on click that basically sends another fetch request. So I'll just copy this from here, paste it here, need to send it to /submission, and the body needs to have the problem ID, which is clean ID, and the submission, which is basically everything in this big input box. And how do we do that again? Well, we create a state variable at the top called submission. Slowly getting very sleepy here, but we're almost there. And then we go to this text area and we do an on change equal to e set submission e dot target dot value, very similar to what we did in the sign up page and the sign in page. We store whatever the user is putting here, something like that. We store this in the submission variable, the state variable right here. And we finally, when we're sending out the request, we send the submission variable out to the backend. Let's do one thing. What are we missing here? Come on, tell me in the comments. Something very obvious we're missing. Come on, you guys can do it. I am very hopeful you can do it. What are we missing? This won't work. Why will this not work? Very important. You need a hint. I need to pass in the token in the header, because how does your backend know who is this person? They'll know because they need the token in the header, else your authentication will fail in the middleware right here. Needs to extract the authorization header. So make sure you're passing in the authorization header here. Where do you get it from? Get it from the local storage. Local storage.get item token. Here we go. I think this is good enough. Let's also log the response here, and then let's try to submit this problem. Inspect network, submit code, and we're doomed. I think this is inside a form. Yeah, let's make this a div again. As you can see, these are like similar problems that you'll face, and like this becomes like muscle memory after a point. Problem / problem 1. Put in some random code here and then click on submit code, and you get back 200. So I think we're good to go. Got back a status WA. So we're actually doing very well here. If you actually look at the headers, we're sending the authorization header right here, basically sending in the token from our local storage, this token right here, in the request as a header, the authorization header. And that's how your backend knows who this person is and is basically storing it there. What's left now is a section right here where you do a fetch for all the submissions, the existing submissions of this user, and show them here, basically WA, AC, WA, AC, maybe the timestamp at which they were put. But this is the gist of a full stack application, front end, back end, connected together very well. Leetcode.com, the best programming platform out there. If you go on problems, these come from the backend. If you click on a problem, the problem comes from a backend, and you can make a submission on your problem, and it returns you randomly WA and AC. I'm going to now deploy this on the internet, and so you guys can all see it on neatcode.io. I'm going to keep it alive there for a few days. As you know, this is not the best app out there. It's like the backend is shaky. It doesn't have a database right now. If the process ever exists, which it will at some point, some exception will be thrown, all the data will be lost because it's all stored in memory. It's only present as long as the process is running. As soon as the process dies, the data goes away. These are inconsistencies we can and will fix in part 4, part 5. But for now, this is a good full stack application, front end, back end connected and deployed on the internet. Let me know what you need to see in the next video. We could either go through the steps of how I deployed this on the internet, or to connect this to the database. I think that's fairly straightforward. If there's something needed there, it's like a full database video, but like not exactly how you can connect this to database, like fairly simple. 3, if no one does it, I will gift myself AirPods, another pair, and I will show you how you actually run someone else's backend code or someone else's C++ Java code in your own backend. What's the right way to do it? Replit does this. If you guys heard of Replit, it's basically a platform that lets you compile, or even like CodeChef, Codeforces, all of these companies, or even LeetCode, of course, lets you run Arbit code in their backend servers. It's a hard problem to solve, not very easy. Replit, if I'm not wrong, uses Nix, which is also a containerized environment from what I know. I haven't looked too deep into it. If we do it, if no one else does it, we'll be using Docker containers and something called as Docker volumes. And I'll show you, like, I've done this in the past once, so I sort of know how to do this, but I'm genuinely hoping one of you guys can do it and win the pair of AirPods. So with that, let me deploy this on the internet. Let me know what you guys want to see in the next video. I'll see you guys in the next one. And in Dubai, hopefully, my flight is in 4 hours. My flight is at 10 in the morning, which means I have to leave at 6 in the morning, and it's 2 right now. So I only have like 4 hours of sleep, but anything for YouTube. Cool. Thank you, everyone. I'll see you guys in the next one. Bye.